Hello everyone, welcome to pipeeng.com. Today we would like to make a tutorial video to introduce one of our popular HDD tools with a focus on the frac-out analysis. So if you have designed HDD projects, you probably know that the frac-out analysis is a very critical part of the risk assessment. Especially when you are drilling through the water bodies or wetland, to know the frackout potential and understand the risk and make planning to mitigate the frackout analysis is a vital part of the project. Okay, let's take a look at the tool itself. So like all our tools offering in on our website, we offer the two different unit functions, one for imperial units for the folks working in the US, and for other engineers, designer outside the US, we do offer the metric units. So before you start, make sure you can select the right units for your projects. Throughout this tutorial, I'm going to use the imperial. The first part of the tool is comprehensive graphs. Pretty much included all the critical data you want to see for a frac-out analysis. As you can tell here, we can have the ground profile, which I can let you know how to load it in a minute. We have the HDD design profile, and also we have the calculated minimum necessary annual pressure to make this drill happen. And also we have the calculated maximum allowable annual pressure. Pretty much you want to see this maximum allowed pressure is going to be over the minimum necessary pressure, obviously, but you can tell for this particular example, towards the, I think this is the exit point, that actually the maximum allowed is lower than the minimum annual pressure. So this is what we can tell, probably going to have some potential for frac out, and as a designer, we probably should do some mitigations. So this is just overall view of what we typically see, and there's some unique features I want to introduce to you guys. For example, you could potentially hide some of the graphs, calculated graphs, by clicking this legend on the bottom. Also, you can tell on the left side, this is annual pressure scale. This is the stationing of your pipeline, and this is the elevation you put it in. Okay, then let's take a look at how we load the ground data. This is essentially the same feature we have for another HDD tool we offer. That tool is focused on HDD design itself, but there's a lot of similarity of this tool to that one, and we try to keep consistent. So if you subscribe to both tools, it's the learning curve is a little bit a lot more less. So for example, for the ground surface data, if you open this button, this is to show you the preloaded ground stationing versus elevation, pretty much profile data. So in that demonstration, to do that, there's to load your own data. There's two ways of doing this. One is to manually put it in. Another one is that you could have your survey data, for example, and you can copy paste in. So I will show you both. So in this case, I'm going to clear the data first, and then you can see all the ground data, everything is gone. And you reopen this, you probably see it's now is available. So let's say you could say, generically, you have started with the station 1000, and your elevation is 912. Then you can go to 1700. And you can call it 905, for example, like that. Then you click load. Of course, this is not perfect. I just want to show you roughly how you manually load. It's very simple. You pretty much just type it in. You can use the space to segregate the stationing elevation, and then you add another line. Or you can add more points if you want. Um, but this is just a manual way to load the ground profile data. What is more common, for HDD design, we will have a survey data, right? We will have a topographic data obtained from a surveyor. So in this case, I'm going to show you how to do that copy pasting, which is very, very convenient. So let's clear the data again, and we go here. So let's say this is the preloaded data, and then let's say in an Excel sheet. So what do you first? You can just put in different line. Like first the row is stationing, second is elevation. You just need to copy the number part, the data part, and you come here, go all the way to the end, and you say copy, right? And you come back here, open again. You can just paste right here and click load. Everything's ready. We're gonna be here. So that's how you load the ground profile. So once you load a ground profile, the next step is to really looking at your HDD design itself. This is the HDD path geometry design, which is no different than your typical HDD design. So this number has to match what your HDD geometry is. This is all the typical inputs like entry point elevation, stationing, entry angle, radius of curvatures, depth of pipe at a horizontal section. This means the depth of the horizontal section in terms of the entry level. So whatever this elevation is going to be. And then exit angle, radius, point of elevation, and stationing. So it also gives you the section length of a different section. Again, this is pretty much the same as the HDD design tool. So I won't spend a lot of time on this. I trust you, you are familiar with this HDD geometry design. And then scrolling down, you will see like the pilot hole and mud properties. There's typically this data you have to get a confirmation from the contractor to select get a confirmation from the folks actually doing the construction installation. But there's some typical data you could use, and then if you know those parameters, you can put that in. That include the mud unit weight, water unit weight. This is standard plus viscosity and yield point. So there's a little bit of mud design you have to understand, or at least know the typical values for your project. So that's basically the second part of this tool. And we going down. This is gonna be the main calculation parameter section. I'm gonna going through going through this line by line, and so you understand what to use. So the first few lines here, this is calculated based on the HDD geometry inputs you put it above, and what is really gonna focus on is is gonna be the geotech input section, which is below. And again, stationing, everything soil cover is already pre-populated. This is gonna cover from entry to exit point. And the nearest borehole, again, this is an example. So, when we design HDD, we will need the borehole data to support the design, make sure we are going through the competent soil layers, and it's also going to help in the frac-out analysis because different soil properties will means different frac potential. So this is this line is really just to give you a little bit of reference on what borehole data your following properties based upon. So it could be, in this case, we only have 2 boreholes, but you could have a 3, you could have 4, depends on how long your HDD is. To do that, to manually put in a different value, you could say clear to clear everything out, like this, right? So once you click the button, everything's out, and also depends on how you name it. So it could be different ways of interpret it, stuff like that. I'm gonna fill everything, but you can't know. So this is just to put the borehole number as a reference for the data below. And the estimated soil type, this is the typical acronyms for different soils. I think CL stands for clay. Again, this is pretty standard geotechnical terms. And then based on different soil types, we will get into different estimated Young's modules, this parameter E in PSI. So you could put all those in, and to make it easier for you, we actually offer a typical value table. So this is in case you don't have the exact number from geotechnical report, you could potentially know the type and come in here, and based on your engineering judgment, you could look at the soil type and find the suitable parameter, or based on the range, you could pick the parameter based on your judgment. Again, you can use a clear to finish everything, to just clear everything, and you can manually rewrite it, and you could potentially rewrite it directly just by selecting it, just like what I did here. But if you make it easier to rewrite everything from scratch, you can just click the clear. What that parameter below is estimated Poisson's ratio. Again, that's related to the soil properties. We have this a typical value and range already plotted. So for your reference, if you're not sure, just click this typical value button. It's going to pop up this window to help you to put in some parameters. And there's a estimated shear modules. This is a calculated value based on what you put it in. Again, you could use the calculated one based on the equations, or if you know for sure from the geotechnical report, you could put like a user input value to manually put that in. So you have 2 options. You could either, if you choose user input value, then you could have a potential to clear everything and manually put it in. But in this demonstration, I'm gonna just go with calculated Young's module, and the following the similar things is all the apparent cohesion. This is all the soil properties associated with your soil data. Friction angles, again, should be taken based on the soil types and geotech report. And the water elevation too is the the underground water level that marked on the geotech report. So all this section is gonna be based on the geotech report you see, and the typical values either is presented by the geotech report, or you already know. So this is the main inputs of this calculation. Again, you could go through all that, and once we put it in, one thing I want to highlight is the radius of plastic zone, RP max. This is another pretty critical parameter calculated. There are multiple equations to do this calculation. If you could click select, You could choose a different method, different equations to do this calculation. Again, they're all commonly used in this industry. But the last one, based on the 2 times the borehole diameter, based on the more recent research, this is a recommended equation to use for this parameter. Is basically is improve the accuracy. So for us, we would recommend. That's why our default is the last equation. But if you have a different design basis, you prefer to use different equations, you could just click on the equations, and it's gonna calculate the data by itself. And also, based on the ground elevation, the groundwater elevation, it's gonna calculate the depth of water, and unit weight is gonna be the soil unit weight you put it in. Again, this is gonna depends on the geotech report. After all this done, you will get to the calculation results section, which is gonna calculate all these key parameters, mud pressure, and the minimal annular pressure and maximal allowed annular pressure, which is gonna be generate the graphs you see above. And also, last but not least, we will have the factor of safety calculated. So if you're going back here, based on the inputs, you will see a different graphs automatically plotted here. And you could also click to the factor of safety to really see the factor of safety. Generally, you want to be 2.0 above, but in the case it's lower, it doesn't mean it's gonna fail. It just means it's gonna have a higher risk. So you can have to do your own assessment and judgment to see if you need additional mitigation, put additional measurements to protect the frac-out potential. Typically, the really key part is under the, like I said, under the environmental sensitive area. So in this case, for example, it's going to be the water channel. So that's pretty much is the tool. Again, we, like all other tools in our website, we offer save on the cloud for your calculation. We could download it to the local file, and then you could open this local file by using open features, and it could generate a PDF report and use it for your project. So that's pretty much everything about this HDD frac-out potential calculations. If you have any questions, feel free to drop us an email through help@pipeengine.com, and I'm happy to provide further clarifications for your questions. Thank you.